Hello, welcome to Ethereal Mechanics video number 22. Sorry for the long delay in the videos. I've been moving. This video is about the aberration of general relativity. I've changed the order of the videos because of new developments. My name is Robert Distinti. I'm an electrical engineer. If you want to learn more about me and this series, you can go to the trailer video on the channel, or you can look at video number 1, which is an earlier intro video. Okay, what we're going to talk about today, we're going to review the experiment which brought about the demise of the old ether model. And then we're going to look at how special relativity fixed the problems with those experiments. And then we're going to look how general relativity essentially broke it because gravity sucks. Then we're going to give you a little intro into the next video, video 23, which will be the ether drag model. Okay, so let's go back. The Michelson-Morley experiment was made to try to measure the velocity of the Earth relative to the ether. But they couldn't measure any velocity in any which way. And they reasoned then, well, maybe perhaps the Earth moves with the ether. And then they came up with the dragging model, the ether drag model. If you want to learn more about Michelson-Morley, you can go to video 19. But then they had another experiment which kind of disproved that. They had the thing called stellar aberration, which says light is not moving relative to the Earth. Light is moving in its own reference frame. And let me demonstrate that for you. Suppose this is my telescope, and these M&Ms are light rays coming in at the top. Okay. If the telescope isn't moving, these light rays are going to move straight down and hit the back of the focal area straight on. But assuming that in every instance of time that the light rays move, the telescope moves with it, then in the next instance of time, sorry, my light rays are not behaving, okay, and the telescope moves again, eventually the light's going to be crunched off to the lower right-hand corner. Okay, and that's going to give the false appearance, or the appearance that the star is actually lower in the sky than it really is. Okay, but there's more to it than that. And so what they assumed with this is that light travels with a different reference frame, not necessarily its own reference frame. And so now they have a contradiction on their hands. Does the light move with the ether, or does the ether move with the Earth? I mean, does the ether stationary, or does the ether move with the Earth? And so what they learned about looking into stellar anomaly in more detail, assuming the star is so far away that this is the Earth at one point of the year, this is the Earth 6 months later, and assume that this star is so far away that the angle is almost the same as viewed from the Earth. And so what you have now is you have the Earth rotates about the Sun at 30 kilometers per second, and the Sun moves through this galaxy at 220 kilometers per second. Okay, and what they found is that the stellar aberration is proportional to the velocity of the Earth with respect to the Sun. So as you're moving toward it, you get a 20 arcsecond depression in the angle. Oh, well, let me just say the rotational speed of the Earth matters too. But for the sake of this discussion, that is so small, we're just going to ignore that for now. And then when the Earth is moving away, they get the opposite effect, but symmetrical effect, that you get a rise of 20 arcseconds. Okay, and this shows that the aberration is proportional to the velocity of the Earth with respect to the Sun. But wait, what about the velocity of the solar system? I mean, in the example I showed here, the true velocity of all components with respect to the ether should be the stellar aberration, but it's not. Okay, and in fact, the Sun is moving 7 times faster. You would think that that would work, so there's got to be some other explanation. So I ushered in special relativity. And what Einstein pretty much said, and this may be a paraphrasing, is that the star being observed, the source, is likely to be a close neighbor, and it would be moving at nearly the same velocity as the Sun. And special relativity states that only the relative motion, that's where you get the word relativity, of the source and detector matter. And, okay, so when we go back to the stellar anomaly, because we are moving, the net velocity of the Sun cancels out. And therefore, all you're left with is the relative velocity between all of the components. And because of this, because we're moving 30 kilometers per second with respect to the Sun, we also notice the aberration when we view the Sun, another aberration when we view the Sun. And so it looks like everything's all wrapped up in a nice, neat ball. But let me just reiterate. As long as the emitter and the detector are moving together, the effects observed will be the same as if both were standing still. And I'm going to demonstrate that in a second with a train example. So therefore, the actual reference frame of light, the ether, is really of no relevance. Okay, and let me explain it using sound waves, because they work the same. That's what I've been saying since video number 4, that they are all waves on a medium, and so they should all behave the same. So it seems like we're cool. So let's take a train with a horn and a conductor that's riding with the train, a linesman that's stationary, that's fixing a line behind the train, and another lineman doing something in front of the train. Well, if the train blows its horn, everyone's going to hear, and everything's stationary, everyone's going to hear the same tone or frequency of the sound. Okay, but then you put the train in motion, and the observer in the direction of motion is going to hear a higher pitch because the sound waves are going to be compressed. The observer behind the train is going to hear an expansion, or is going to hear the tone of the frequency go down, deeper, because the sound waves are being stretched apart. And the interesting thing is the conductor in the train, because he's moving into those compressed sound waves, is going to, or I'm sorry, those stretched sound waves, he's going to compress them back to normal. So he's going to hear the normal tone of the train. So it's as if, because he's moving with the source, he can't detect the motion because he's moving with the source. And so it doesn't really matter now. It doesn't really matter what the velocity of the air is. Okay, the air could be moving at 100 miles an hour and it won't matter. All that matters is the relative motion between the detectors and the source. Okay, and so we go back to the Michelson-Morley experiment. Sure enough, you know, if this is moving through the ether, okay, then there's going to be zero Doppler shift, and they also reason that there should be, that all of the measurements that are made should be the same as if you're standing still. And that would include the speed of light as well, and so they included length contraction, which we talked about before. So they reasoned, probably rightfully so, that as long as the detector and the emitter are moving together, you should not be able to detect whether you're moving or not. Now the problem with that is, okay, special relativity took hold, and the ether was forgotten, because obviously if you can't detect it, it's really of no use to talk about. It wasn't disproved, okay, so let's be clear. The observation that the velocity of the air has no effect on the observed sound of the train whistle does not disprove the existence of air. And likewise, the observation that the velocity of ether has no effect on the observed effect of light does not disprove the existence of ether either. If air is detectable, so should the ether. So it looks like special relativity has everything all wrapped in a nice, neat package. So what's the problem? Well, 11 years after special relativity resolved all the problems of stellar aberration, Michelson-Morley, and long after scientists forgot about it and moved on, Einstein published General Relativity, which now includes gravity, which is a force which they propose to bend, that they claim that bends light. So now we have a problem, because special relativity supposedly left us with a complete solution to Michelson-Morley and stellar anomaly. So any new scientific principle comes along which also claims to bend light is going to offset the balance. Unless, of course, the bending of light relative to gravity is insignificant, then it won't matter. So what are the effects of general relativity? Well, Carl Schwarzschild reasoned that the bending of light is related to escape velocity. And this is how he derived the equation for the event horizon of a black hole. Okay, so now if we include escape velocity into the stellar anomaly, well, we have the normal velocity of 30 kilometers per second, and on this side of the sun, the escape velocity for something trying to leave the Earth is going to be the combined escape velocity of the Earth plus the sun at this point in space. Okay, so we're going to get, so this would have an effective velocity of the Earth in this direction of 53 kilometers per second. On the other side of the sun, the combined effects for the escape velocity of the Earth and the sun is going to give us a effective velocity of the Earth, not a real velocity, an effective velocity, the velocity you could use to determine what the bending of light should be. And that's going to come out to 29 kilometers per second going away. So if we apply these back to the other diagram, okay, our 20 arc second depression in light is going to be thrown the other way with a plus 36 arc second correction due to gravity, which is going to give us a net positive deflection of 16 arc seconds. On the Earth moving away, the motional aberration is going to be almost completely canceled by the gravity-induced aberration, and we're not going to see a deflection. Okay, so we have a train wreck here. general relativity seems to derail the solution offered by special relativity. And this often happens in science. You know, we solve something and we leave it, and then we go on to other stuff and totally forget that when we develop something new, we got to see how it affects all the old stuff. This is part of software engineering. When you add a new feature to a software product, you got to go back and retest all the other features. Okay, we got to be applying this to science too. Okay, but regardless of whether you believe in relativity or whether you believe in ether or whatnot, gravity does bend light because we have observations that say it does so in fact bend light. So we have to account now for stellar aberration and Michelson-Morley a different way that accounts for all of the effects that bend light. And what I'm going to show you in the next video is an ether whirlpool effect, which fixes a lot of other problems, including dark matter. Okay, and like all medium-borne waves, all medium waves move with their medium. We have to understand the complete behavior of the medium to resolve the stellar anomaly in Michelson-Morley, as well as the dark matter nonsense. So what's next? I've rearranged the videos. Before I was going to start out here and go into Earth. I've turned them completely around because I want to start from the Earth and move out to the galaxies, because stuff out here is mostly conjecture. I didn't want to start Distinti's universe on items that were mostly conjecture. I mean, it's conjecture for present science too, because until we actually go to the edge of the universe or go beyond the galaxy, anything we do right now is just based on our guess is based on observations, which are mostly conjecture. All right, so we're going to do the new ether drag models pushed to 23 because I needed to get this in. Then we're going to talk about the Earth and the Moon, the oceans, and there's a conjecture on where did the crude oil really come from. This is just conjecture. Oh, we're going to talk about planets first, and then the end of it we're going to have a little conjecture about crude oil. Then we're going to talk about the sun. This one is going to be a lot of fun. I'm going to show you most of what we know about the sun, I think, is completely backwards. In other words, I'm going to be able to explain, well, that's in the next slide. Then we're going to talk about planetary orbits and precession, and we're going to talk about black holes and a new material I call galaxium. And then we're going to look at how galaxies and the multiverse formed. This I stole from Lady Gaga. And then we're going to get into new math. Everything after this is going to be pretty much hardcore math and electromagnetism. At video number 30, we're going to end the logic. Because what I do first, I like to do the logic, reason everything out. Then I like to go into the math to back it up. So, yeah, we have homework for video number 27. I'm going to post these links if I figure out how to do that. But there's a YouTube video by a British BBC about the secrets of the sun. And what I need you to look for, okay, this is your homework. Write this stuff down when you watch the video. You can, you don't have to, but it'd be good if you watch this video first. Look for what are sunspots, why do scientists think they're dark, how are they related to solar output, is it just a correlation, where is the light of the sun made? They say it's made in the core. I'm going to show you it's made on the surface. And what is the core of the sun made of? And how do they know this? Look at the silliness that they go through to try to figure this out. And I'll show you there's a big flaw in their logic. Okay, and what is the mechanism of the sun? Is it fission or fusion? Okay, if people that read my previous papers will know how I'm going to answer that one. Okay, in number 26, oh, this should be 27, sorry. I'm going to show you that there's a different way to put all of these observations. You know, you can explain your observations with one model, but there might be a completely different model that explains the same observations, and I'm going to show you a completely different observation when they show. And if you go through the video and you write these things down, you're going to see how backwards my theory and their theory are, or how different they are, let's put it that way. Thank you for people contributing. Really helped out. I was able to buy repair parts for my printer to keep going. If you want to donate, go to my website, distinti.com. The website's not up to date yet. I've been trying to update it, but it's more important to get the videos out. There's a donate button if you could donate and help. And please get the word out. I don't have time to go out and start. People have asked me to go on their websites and, you know, be like a guest or whatever. I don't have time to do that. My cancer is back, and I need to pump these videos as quickly as I can in the little free time that I have. So if other people could get the word out, I'd really appreciate it. And give me thumbs up. And and it would really help if you sit through the commercials. I think I get a better, I don't really get much. Getting like 11 cents a month with the amount of traffic I got, but you know, whatever helps. Anyway, thank you.